Hey guys, so welcome to the last lesson in Chapter 9. We're going to talk about composite or compound figures, okay? And we're going to figure out the area of the shape that doesn't have a formula because it doesn't match any shape that we know of, okay? So let's go ahead and give ourselves a definition of what is a composite figure. And I wrote the word compound in parentheses because some people call it a compound figure. So I just want you guys to know that those are kind of interchangeable. So it's a figure, which is a fancy way in geometry of saying a shape. It's a figure made up of two or more two-dimensional shapes or figures with recognizable area formulas So what that means is that we could have a combination of a rectangle and a triangle, or a trapezoid and a triangle, or any kind of combination of shapes that we actually do know how to figure out their areas of. So to calculate its area, we're going to break the composite figure into its two or more figures. Find the area of each, then add those areas together. So you're still going to find an answer that has square units, but we're breaking it into smaller pieces that we know how to calculate the formula for the area of that particular shape. So we're going to do actually a total of 4 examples, and that's the rest of our notes. So this is going to take 2 pages for you, and it may take me 2 screens for the first page, and the second page will fit on a third screen. Okay, so let's see the kind of stuff we might end up with. So first one says the dimensions of the city pool are shown. What would be the area of the pool's surface? Now, if it was talking about how much water is in the pool, that would be volume. But we're just talking about if you looked at the surface of the pool, what would that area be? Okay, so let's go ahead and draw a shape. And, you know, with pools, you tend to have like a step down. And the steps get wider and wider. Okay, and then a lot of pools are just rectangular. Like an Olympic-sized pool. So I'm going to put some values in here. This is 28 feet. This side is 14 feet. At the widest step, it's 6 feet. At the narrowest step at the top, so this is like on the deck, that's going to be 4 feet. Now, I'm not drawing anything to scale, just to let you know that, okay? All right, and then, so that we can see it, there is a height, and that is at 2 feet, okay? So if you notice, that step down, that is a trapezoid. So we're going to go ahead and figure out the area of the trapezoid. And to that, we would need to combine it with the area of the rectangle. Or we could call it a parallelogram, right? Okay. So I'm going to start with the information that we have for the trapezoid. So I know that its one base is 4 feet. The other base is, sorry, not squared, sub 2, is 6 feet. We have the height of that trapezoid is 2 feet. Okay, and that's all the information we need, because the formula for the area of a trapezoid is 1/2 the sum of the bases times the height. So I just plug the numbers in and I solve. So I get area equals 1/2 the sum of 4 plus 6, and then we're going to multiply that by the height, and the height is 2. So I simplify first. I get area equals 1/2 times 10 times 2. Half of 10 is 5. 5 times 2 is 10. Now this is going to be square feet. So that's the first area. Okay. Now I got to figure out the area of the rectangle. So again, we're going to list out what we know. And we've got a length that's 28 feet. And we have a width that is 14 feet. So formula for the area of a rectangle is just going to be length times width. And we're going to get area equals 28 times 14. So off to the side of my paper, I'm going to do that calculation. 28 times 14, we get 32. We get 4 times 2 is 8, plus 3 is 11. Put in a placeholder. 1 times 8 is 8. 1 times 2 is 2. And we get 392. So the area of the rectangle is going to be 392. I'm going to write square feet the other way. Even though it looks like feet squared, we don't ever read it like that. We say square feet. So for the pool's surface, we're going to put it all together. And we're going to have 10 plus 392, and we get the answer is 402 square feet. So that's what a composite figure is. It's made up of more than one shape. Now, I didn't put a number there, so I'm going to put that and call that number 1. Let's do number 2 over here. Directions are going to just say find the area. Oh, this is an interesting shape. Let's see if I can draw it accurately. Again, this is not to scale. It kind of looks like a Santa boot, or like a tall Ugg. All right, let's put in some numbers here. This left side is 10 feet. The bottom is 12 feet. The right side is 4 feet. And we've got 8 feet for the horizontal side from here to here. Okay. And then, so they haven't broken this down, so our job is to try to figure out how to do it. So the first thing I need to do is to decide how to figure out the area of this shape. And I actually see a couple ways I can do it, but I'm going to break it down into the same 2 shapes that we had in the first problem. So I'm going to draw a line. vertical line, and that's going to separate the boot part from the calf part of the shape. So it's going to break it into a trapezoid and into a rectangle. So first thing I'm going to have to do after I determine my shape, I guess maybe I should say the second thing is we're going to find the missing dimensions. Oops. I don't know where D came from. Probably from dimensions, right? So, in other words, I need to know for a trapezoid, what are the two bases and what's the height? And with rectangles, I need to know their top and bottom, right and left sides, okay? So we are missing a couple things here. For the trapezoid, since this is a rectangle, across from the 4 feet would also be 4 feet. Now remember, that 12 feet on the bottom goes from edge to edge. I'm going to draw that in there. It goes all the way from there to there, okay? But to get the height, remember trapezoids, it's got to be at a right angle. So I need that horizontal distance from the 10 foot to where that red line is for the height, which in our case is actually the base of the trapezoid, right? So let's see, for this guy, I've got 12 feet, but the length of the rectangle is only 8, so that gives me 4. So that says this piece is 4 feet. Okay, so now I'm going to figure out the area of the trapezoid. Okay, so I'm going to get A equals 1/2 the sum of the bases times the height. So I'm going to plug in the numbers, and I get area equals 1/2. And the two bases are the 10 and the 4. And the height is that, so the 4 that's vertical next to the red line, that's a base. And then the height, so the distance from the top base to the bottom base, because remember, we can always identify bases because they're the two sides that are parallel to each other. Okay, so, okay, simplify and solve. And we get 1/2 of 14 times 4. Well, half of 14 is 7. And 7 times 4 is 28. So I get 28, and it would be square feet. Okay, that's the first one. Now let's go ahead and figure out the area of the rectangle. So that was the second thing. Let's do third thing. Area of the rectangle. And so we're going to get area equals length times width. So our rectangle is not a 12 by 4, it's an 8 by 4, okay? So we're going to get 8 times 4. And that's going to give us an area of 32 square feet. So first thing we did was figure out how to break the shape up. Second thing we did is figure out the missing dimensions. Third thing we did was find the area of each of the pieces. Now we only split it into 2 pieces. Sometimes we can split things more than that. Okay, so now we're going to combine the areas. You hear the siren? And we get 28 plus 32. Let's see, we get a 10, we get 5 and 1 is 6. So we get the answer is 60 square feet. Okay? All right. So the last 2 problems I'm going to share with you on my next screen, which would be my second page. I did get these all on there. I'm very proud of myself. are going to be some kind of unusual cases, okay? The first two are kind of basic. The shapes are pretty easy to figure out. This one's going to be a little bit more interesting. So again, I'm going to title this page, oops, hit the wrong thing, Lesson 9-6, Area of Composite Figures. Okay, all right, so well, there we go. Let's see, hopefully I can draw. Example 3, find the area. To the point, straight, simple. However, our shape may not be. Oops, need to erase a little bit. Okay, and right angle, right angle, right angle. And we're going to have some information here. So we've got 5 meters. At the top on the left, we've got 10 meters. Bottom 7 meters. Right side 7 meters. Okay, so this is not a trapezoid, okay? Because there's 1, 2, 3, 4, 5 sides, and a trapezoid is a 4-sided figure. So we got a problem here. So some people might think to do this. Okay, and we could probably figure out the area of that trapezoid. But I'm going to do a little different idea. Okay, you might have thought of that one already. But what if we do something like this? If I add a corner, now I have a rectangle, right? So what I'm going to do is figure out the area of this little triangle, and then I'm going to figure out the area of the rectangle, but that rectangle now has that invisible triangle there, so we're going to have to get rid of it. So we're actually going to do subtraction on this problem. Yeah, crazy, huh? Okay, so first off, we got to figure out dimensions. So I have now a rectangle that's going to go 7 across, because I'm looking here, and 10 up. So those are my larger numbers, so those are the ones it needs to be. Okay, so how are we going to figure out the missing dimensions? Well, here, remember I said the whole length is 7, but I've only accounted for 5. So if I subtract that, that'll tell me what that part of the triangle equals. Okay, and we can do the same thing with the vertical line. The whole line is 10 meters. The whole line is 10 meters. But I have 7 of it below already accounted for. So if I subtract, it's going to tell me what the missing piece is. Okay, so here we go. Let's figure out the area of the triangle. And the key we're looking for when we're figuring out area is we're looking for the right angle. The two sides of the triangle, or the two parts that make up that right angle, are going to be the two that are involved in the formula. So we're going to get A equals 1/2. Now it really doesn't matter who plays the role of base and who plays the role of height, but we can say it's 1/2 times 2 times the height of 3. Okay, so I can take half of 2 as 1, and then 1 times 3 is 3. So I get area equals 3, and it would be square meters. Okay, but then I have the area of the rectangle. Okay, and so we know the formula is area is equal to length times width. So the length is going to be the 10, and the width is going to be the 7. So this is a pretty easy calculation. Area is 70 square meters. So remember, the rectangle doesn't exist. it only exists if I add on that triangle. So if I want to figure out the area of the black outline figure, I'm going to have to get rid of that triangle. So we're basically going to take the area of the rectangle. Oh, I'm having trouble today. Rectangle. And we're going to subtract from it that area of the triangle. So we end up with 70 minus 3. And that's going to give us an area. No, I don't need to write that again. Of 67 square meters. Okay? Now, I can't remember what Alex does. Alex may give you it on a grid and, using the idea we had from lesson 9-5, that we may have to count the number of squares it is long or tall or high or whatever, and to get our dimensions. So that might be something you end up doing. Same directions. This one's super strange. So we've got 2 rectangles, but they interact with each other in a pretty strange fashion. So trust me when I say these are rectangles. Okay, let's get some numbers in here. We have 12 centimeters and 12 centimeters. For the other guy, we've got 15 centimeters and 12 centimeters. And then they give us a little bit more information, and they tell us that above the horizontal line above where the 12 is, that guy's actually 8 centimeters. Now that's only to the edge of the other rectangle. And then this is where it gets a little weird because we're kind of cramming stuff in here. But from that vertical line, from the 12 on top to the top of the rectangle on the right, that's going to be 6 centimeters. Okay? So what we have basically done is created 1, 2, 3 areas, and they happen to all be rectangles, which is kind of nice because that makes it an interesting formula. But here's the deal. Area 3 is part of Area 1, and it is part of Area 2. So if I add the 2 big areas, 1 and 2 together, I count that Area 3 twice. So we're going to take care of that by removing it. So we have the area of 1 plus the area of the second, and we're going to subtract the area of the third. So that's how we're going to solve this problem. Okay? So let's start with area 1. And again, length times width. So we have 12 times 12, which equals 144 squared centimeters. Let's figure out area 2, also a rectangle, but this one is a 15 by a 12. So I'm showing you both ways, or 2 different ways to do multiplication symbols, a dot or the X. And we'll just do the math off to the side. So we get 10 with 1 over. That's a 3 placeholder. 1, 0, 180. That's 180 squared centimeters. And then we need to figure out the area of 3. So we're going to have to figure out some dimensions here. So let's see if we can do it. All right, so from edge to edge on the top of the bottom rectangle should be 15. But I've accounted for 8 of it already. So if I take 15 and subtract 8, I get 7. So that's going to be the length of this guy, so 7. And then over on this side, the left side, let's see, from top to bottom is 12. I can see because opposite sides of a rectangle are congruent. And let's see, what do I know? So we have a 12, and I know from the top of the area 1 to this line is 6. So to go from here to here would be the same as to go from here to there. So let's see, so I've got 12, and I've accounted for 6 of it, so that tells me it's 6. So I'm going to multiply by 6. Okay, and we get 42 squared centimeters. All right, so now let's go ahead and figure out our answer. We're going to take the first 2 areas, add them together, but we've doubly counted that middle little area, so we're going to have to subtract out the one we doubly counted. So this is going to give me 324 minus 42, and then, just off to the side, you can do that math. Oops, 24. I went dyslexic. That happens. And then we're going to subtract. We get a 2. We're going to rename. We get an 8. We get a 2. So we get a grand total of 282 square meters. And there you have it. So that's what you guys are going to be practicing. Last new thing for Chapter 9. All right, good luck, guys. And make sure you have this done Tuesday when we walk into class so that we can go over it and answer any questions you have. All right, see you later. Bye-bye now.